All right, here we go. We're going to get through chapter 2. And again, this video is not intended for you to completely understand and how to do all the calculation. It is intended for you to start learning some of the vocabulary and start on your own learning through what the calculations look like and can I do it on my own. In some cases, the answer is yes. I would say a lot of the times you should be able to do the basic calculation and then come into class with that basic understanding, and we'll do a lot more problems in class to help further your understanding. So let's get right to the displacement and velocity equations. Dimension in one-dimensional motion is awesome. It's very simple. It's a train on a track, a person running down a sidewalk. All of those, you have to start with a simple perspective. In this case, most of the times you are standing on Earth, and that's your perspective. Easy, done, moving on. Now, displacement is a little bit different. State-bound shirts if you want them. Displacement is a change in position from x to x1, or you'll see often case down below, there's the equation, your final position minus your initial position. If you notice on the little lizard, hey, it ended at 80 and it started at 20. Again, it's kind of, so you say 85 minus 25 is final minus initial. 85 minus 25, it went 60, in this case I think centimeters. So displacement, simple, done. Positive and negative. Positive and negative will be the challenges as we go through this. In some cases, you'll see a positive change, a negative change. Understand it's just a direction that it's actually saying. Example on the left, it went from 10 to 80. The final position is 80. 80 minus 10, it's got a positive 70. The negative version of that, it went from 80 to 20. 20 is your final, 20 minus 80, it went negative 60. The negative indicates it went to the left in this case. And you can see more examples. All right, average velocity. Good equation to have. It's just the distance you went over the time it took you to get there. So the change in distance, delta x over delta t. Delta t, again, xf minus xi. The final distance or location minus the initial location. Time final minus time initial. Your label should be meters per second, or m over s. Velocity and speed. Velocity is two different things compared to speed. Velocity has a number with a meters per second, 27 meters per second, north. Here's the idea. Speed. If I say you're going 27 miles an hour, you have no idea where you're going, what direction you're headed, nothing. You just know it's the number. Now, velocity has a direction and a speed. If you're going 27 miles per hour north, you can tell out where you're going to go. Average speed, again, average speed, distance divided by time. Time graphs. Let's get right to a graph. So position and time. If you're looking at the position, so time is going this way. So 0, 1, 2, 3, 4, 5, 6. So if we start with this first line, we can honestly say from our position, the object is going away from us. Time's going this way, position is going from there. So object 2, there's no slope to the line, there's no change, so there is no velocity. This one is getting closer to us. Object 3, basically coming down, getting closer to 0, so it's a negative velocity. One is a positive, negative. Slope indicates your velocity. The bigger the slope, the faster it's moving, or the higher the velocity. So, now, hard time, for some of you in calculus, you should have already understand what a derivative is, or if taking calculus, there's very few of you. Instantaneous velocity is that one snapshot of one picture at one point in time. That's it. Example, you drive from here to your grandma's house. You say you were doing 70 miles an hour. No, I don't think you were. You might have averaged 70 miles an hour, total distance divided by total time. But instantaneous velocity at 70 miles an hour, I don't think you were doing 70 every time. I mean, you turn into grandma's house at 70 miles an hour, she might be upset. Just FYI. changes in velocity. Now, this is taking the velocity equation and putting it to how fast you are changing that time, speeding up, slowing down. One of the annoying questions you'll hit is acceleration versus deceleration. One is slowing down, one's speeding up. The problem is acceleration doesn't say, oh look, it's a positive. There could be a negative acceleration. We just have termed it deceleration in the English language. Makes people easier instead of saying a negative acceleration. You'll hit a lot of those. Anyway, average acceleration is a change in velocity over the change in time. And again, it's the final velocity minus the initial. You'll see that a lot, the final minus initial. Example, change in time, final minus initial. So, object accelerate, you can actually have the speed, direction, and both of them change. This is where it kind of gets hard, and we'll talk about this more in motion in three-dimensional, because honestly, you can change the angle of a turn, which changes the time, the velocity, and the direction you're traveling. It's kind of harder to do. That's why we're going to stick with motion in one dimension for, I think, 3 days. So, example, take a look at this one. So if I'm going up, what's happening to my velocity? My velocity is increasing. At A, my velocity is still going up. So it's a positive acceleration. Here, at B, it's flat. So it's fairly constant, so there's no acceleration. And then down on this way, my acceleration is negative, so it's starting to decrease. So my velocity is getting higher and higher and higher, staying the same, and then decreasing. Easy way to think about it. Easier. And there's the velocity, acceleration, speeding up. The velocity negative. You can go through this. I'm not a big fan of these charts, but for some people it helps. All right, you might as well take the time on page 58 in your book, write these equations down. Write this whole chart down in your notes, star it, because we'll use it over and over and over again. You will have to use this all first semester. You'll have to use these equations over and over and over again. The left-hand side, if it has an initial velocity, meaning you're driving 27 miles an hour, and you speed up to 30 miles an hour, it takes you 3 seconds. Look at that first equation. How far have you traveled? Congratulations. This is the exact same equation, but with VI as 0, meaning you're at a stopped. You're at a stopped, really. You're stopped, and you speed up to 30 miles an hour, and it takes you 27 seconds. You can use this equation. There is nothing to say you cannot use this equation and put a 0 in for VI. Same idea, same equation, same resultant. If it's not, let me know. We got problems. You will use these equations over and over. Make certain. You might want to pause the video and write them down. So here we go. Sample problem. You're pushing a stroller, starts from rest, accelerating at a rate, velocity of the stroller if it's traveled 4.75 meters. Okay, so in this case, what do we know? We know our initial velocity is 0. We're at a stop. Acceleration is 0.5. Our distance is 4.75. Okay, you should be able to do this for every single problem. I'm going to recommend it. I'll do this on the board. If you can do this, half your work is done for you. And on the test, if you completely blank out, you should at least give me a label for the final velocity. In this case, the initial velocity is in meters per second. Guess what the final velocity label should be? Meters per second. The idea is that's a point automatically given to you. You're good to go. So we have a problem. We need to find VF. With those given variables, we go back to our handy dandy chart. Seems like that one's pretty simple. Oh, I guess we could use that one. Because what do we have? We have a distance, we have an acceleration, we have a velocity. Do we have a time? That's got time in it, that's got time in it, that's got time in it. No time. VF, VI, acceleration, delta x. Ooh, we might have a winner. Are we at rest to start with? So our time is 0. Hey, look at that, even simpler. Vf squared equals 2a delta x. I think that's a winner. What do you know? So do they. Now, this is where myself and the slides I present will differ. I do not rearrange equations. I don't do it, don't like it. It becomes alphabet soup. I'll show you those in the notes, but in class, when I go through it, I will put everything in and solve the math you can and then simplify it. For me, it just works better. Okay? So, this is their math. The square root of 0 plus blah, 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 blah. 2.18. Does it make sense the velocity is that high? Yeah, I thought it makes sense. Stroller's velocity of accelerating for about 5 meters is to the right. Okay, I can buy that. Free fall. We'll talk about free fall a lot. Acceleration due to gravity. You have symbols A, G, or just G. If you take AP Physics later on, you'll just see G. Oftentimes, I'll write acceleration due to gravity. So, understand there is a huge difference between mass and weight. We'll talk about, but acceleration due to gravity is a constant for the most part. We'll talk about some unusual cases after a bit, chapter 3. This book uses acceleration due to gravity is 9.81 meters per second squared. You should be able to get that into your brain. You will use it over and over and over again. Okay? Technically, it is negative 9.81, always pointing to the center of the Earth. I'll tell you right now, I don't use negatives as probably as much as I should. The idea, though, is it is a direction. Just like we said before, acceleration and deceleration. It's a negative direction. It's going down. So, sample problem. So you hit a ball straight up. And first of all, reality check. Does the ball go up forever? No, it goes up to a point and stops and comes back down. Does it go up at 6 meters per second and then all of a sudden, stop, and then come back down at 6 meters per second? Hopefully you said no. If not, we got problems. That being said, things you're given. Initial velocity. You should understand acceleration is negative 9.81 meters per second. Delta y is negative 2. Okay? So now we go back to the handy dandy equations. Again, what are we looking for? Time it took. So wait a minute, I don't see a delta y in any of these. Let's go back to the equation. So I've got initial velocity, I've got acceleration, and a delta y. One of the things you'll get good at is interchanging delta y and delta x for these equations. So I'm looking for t, I have a distance, I have an acceleration, I have initial velocity. So back to my equations. Which one can I use? Well, wait a minute, all of them use final velocity. Is there something that we haven't accounted for? Before it strikes the floor. So, we've got a 6. So what equation would you pick? Either one will work. The good news is you can pick either one, and this is where my answer key will be twice as long as your work, because I have to see if this one and this one. That way I understand your work. Go, okay, you made a mistake or a math mistake there. So right now we're just going to pick the left one, and I'm going to choose it. So in this case, I know my velocity, initial velocity, positive 6 meters per second, my 2 times acceleration, negative 9.81, and negative 2 meters, because it went from how high you threw it to the floor. And there's my final equation. You do get a positive and a negative, but in this case, it's going down, so you should pick the negative direction. Now the time. Notice we put in the time, VF minus VI, A gives you delta T using that other equation. and that gives you 1.50 seconds. Now notice, one of the things we've kind of sat there and said, oh, there's my pup. Is this logical? Is this the right number of significant digits? For adding and subtracting, it's the number behind the decimal. So there's 1 behind the decimal, 1 behind the decimal, we should have 1 behind the decimal. There's 3 significant digits, 3 significant digits, 3 significant digits. 1.50 is the correct answer. And last slide. Oh, there's my puppy. That's a good picture of her. If you have any questions, we'll start this class and work through.